Looks like we've got some good weather finally this morning. Welcome to the Transportation Infrastructure Durability Conference. We appreciate everybody joining us today. Just a bit of logistics. We're going to have all of our meetings here, but right through that door on the to my left, right over there, there's some displays that you probably want to see. Right over there, also some conference presentations that the students and posters have put together that through that door, and also right on the other side. So if you want to go and during the breaks and take a look at the displays, as well as the sponsors displays out in that room. So I'd like to first thank the many sponsors of the conference today. You can see their names up there. Just take a minute and ask the sponsors to stand up and be recognized. If you're up there, I know they're there, or they must be out in the other room. Okay, all right. Here's one sponsor. Well, we appreciate all the sponsorship. We'd like to give you all a hand. Thank you. The hosts of the conference are the University of Maine, the Maine DOT, and the University of Vermont. And the conference committee includes a number of people that worked very hard to make it happen. Dale Peabody and Dr. Hassan Ghazenfari are the co-chairs of the conference. I'd like to ask them to stand up and be recognized. Dale? Yeah. Thank you. And also Jim Bryce is the panel's selection and agenda creation lead, and also the manager of the TIDC program. Jim, you want to stand up? Yeah, thank you. Aaron Shank did a lot of work with logistics, communications, and marketing. Aaron. Amanda Collmore also did a lot of logistics work. Amanda is also part in the Maine legislature. Amanda. Jenna did some administrative logistics. I think Jenna might be outside right now, still doing logistics. Vu Fan did a lot of the financials and does the financials for the Transportation Center as well. Vu, he must, yeah. And then Taylor Ward did a lot of the marketing and logistics. Thank you, Taylor. She's right in the back. She's a ball of fire. So I appreciate all the hard work they took to pull together the conference. This is our program for day 2 at a glance. So right after this, we're going to have a keynote speaker, Dr. Robert Mosier, and then we start the sessions. The first session is driving research to deployment. One of the big challenges we have is there's a lot of research going on, but how do you actually make sure the research gets into practice? So the theme of this is how to take research and get it into practice. It's a big issue, as you know, and everybody struggles with that. So looking forward to the panel and some of the thoughts you all have on doing that. Yesterday, we had a great talk along the same lines by Sid here from the National Cooperative Highway Research Program. So Sid will be on the panel as well. We'll take a break at 10:45. Then our first plenary session is Sensing the Future. Basically, how do we measure the conditions of the infrastructure? In the afternoon, we have a plenary session on transportation and composites, using composites in transportation. And we have today John Bissell with us here. John is from the American Composite Manufacturers Association, a dear friend, but also a leader in composites, been in the industry for 40 years. I'd like to recognize him here, John. And then next to him, Joe Fox has also been in the composite industry all his life and very passionate of bringing composites to infrastructure, Joe. Following that, we have another plenary session on geotechnical moonshots. Literally, how do we take geotechnical engineering and improve that to improve the durability of infrastructure? And there's an interesting thought about also a session about using doing geotechnical engineering on the moon. So then at 6:30 we have an advisory board dinner. Tomorrow we have also a number of plenary session. At 9:45 we talk about autonomous vehicles. At 11 o'clock, we have an opportunity for you to see the VME lab tour. If you haven't seen that, I would definitely urge you to go do that. The lab is fantastic. Basically, they get you to go sit in a vehicle with some goggles on, and you think you're actually driving around, even though you're standing in the same spot. So they can take you through a city and so on and so forth. So there's a lot of very interesting work going on in that lab. In the afternoon, we also have an autonomous vehicle session. We also have a tour, I should say, of the Advanced Structures and Composite Center. And if you haven't seen that, I would like to say it's about a 100,000 square foot lab, and the biggest structures and composites labs in the United States, with 400 some people who work there. So love to have you come and take a look at that as well. Going back to the conference itself, the Transportation Center that's put the conference together is called TIDC. The goal, our mission, is to develop innovative, sustainable, next generation solutions to improve the durability and extend the lifespan of transportation infrastructure in New England and beyond. As you know, all of us engineers, whether we work at the DOTs or in private practice, we're always trying to figure out how to build bridges that last longer. And we work very hard on that every day. So the purpose of this Transportation Center is to work together with all of you to figure out how to drive this technology forward. How do we make a bridge last more than 40, 50, 60, 70, or 80 years? How do we do all that? Is a big challenging part of, and that's what we work on in the Transportation Center. The Transportation Center has 5 universities across New England. You can see them there, and this is the advisory board of the Transportation Center. The way we operate is we work very closely with the state DOTs to identify the needs that they see in infrastructure. What is it going to take to solve some big problems we're having today and we're having tomorrow, and so forth? And so we're very appreciative to the advisory board that's led by Dale Peabody. Now, Dale Peabody has been with the Maine DOT for decades, led research and development. And I'm going to ask Dale to stand up one more time. And he's just retired recently, and it's very difficult to fill his shoes. But he was a great person coming in to take over for Dale. And Dale has been at the national level, managing research, big research programs at the national level as well. But we're so pleased that he's going to stay along and work with the Transportation Center as well. Taylor? Oh, okay. Wow. I didn't see our president here. We just like to take a minute to invite our president, Joan Farini-Mundy, to the podium. President Farini-Mundy joined the university a few years ago, and this is a surprise. I didn't know she's gonna be able to make it because she's so busy. But President Farini-Mundy has led the University of Maine into a transformation of research on campus. She came in as being the chief operating officer for the National Science Foundation. So it was a big coup to get her to come to Maine, but come in New England, where her roots are. It was fantastic to have her here. And but what she's done is she's transformed research at the University of Maine. And 2 years ago, we became an R1 research institution. What does that mean? We became a Carnegie R1 research institution as a top designation for research institutions within the United States. And it puts us in the top 4% of university colleges and universities that do research in the United States. So with this in mind, she's going to say a few words for us. Please help me welcome President Farini-Mundy.
Good morning, everyone. And this was not planned in the schedule, so I'll just be very brief. First of all, I would like to thank you for being here at the University of Maine and welcome you officially. I'm sorry that I couldn't make it last night. Thank you to those who persevered through terrible weather yesterday to get here as well. So it's great to see you all. I hope you enjoy our campus. Just seeing Habib's overview of the program and all that you'll be able to see here, I certainly recommend that you take in as much of that as you can. We are very proud of what we do here at the University of Maine across the fields that are so important for the transportation infrastructure areas in general, and love the fact that we're also partnering with so many of you in so many different ways across New England and beyond to advance knowledge and understanding and solve the problems that our nation faces, particularly in this domain of transportation infrastructure. So welcome to Maine. Have a wonderful day. My next appointment is with the football team, so I will go see them now, but I wanted to be able to say hello to you and wish you well for a terrific conference, and to thank Habib for his incredible leadership here at the university. Have a great day. See you.
Thank you, President Farini-Mundy. Appreciate you taking the time to come and see us. So going back to our advisory board, we couldn't be doing the work we do without advisory board. So each DOT has actually put together, assigned an advisory board member. And I'm going to ask the advisory board members, you can see their names up here, to please stand up and be recognized for the work that you do. So, yeah. Thank you very much. And the advisory board members actually get to review all the proposals, research proposals that we work on and rank them and provide input. They also assign each of the research projects that we do has a champion assigned by the DOT that works with the researchers to make sure the research results end up being used in practice. Now, that's very unique and doesn't happen very often. So we're very keen on taking our research and making sure it gets used and it solves some real problems that the DOTs have. So thank you again for doing that. The other group of people you see up here, I'm going to not name everyone here, but we have Jim Bryce, as I said, who is the manager of the transportation center and comes from industry in the construction industry, decades in the construction industry. Jim, you want to stand up one more time, please, and be recognized here. And he's the heart and soul of pulling this whole program together. And then we have a number of faculty members, both at UMaine as well as through our collaborating universities that have really led the program over the many years. So you could see their names out there. And I'd like to take a minute to ask them to stand up and be recognized. So please stand up. Thank you. Now, how are we organized? Our goal is to essentially figure out how to make things last longer out there. And to do that, you got to first, we've broken up into 4 thrusts. The first thrust is figuring out what's wrong. So basically, putting sensors on bridges and infrastructure and figuring out how it's degrading. Because the first, to solve a problem, you got to figure out how big the problem is. So that's thrust 1 is monitoring the infrastructure using next generation sensors. Step 2 is developing new material systems, whether it's new materials made out of composites or advanced concrete or advanced metals. What are the material systems of the future we could use to extend the life of our infrastructure? That's thrust 2. Thrust 3 is structural systems. How do we put materials together into a system where the system actually survives the environment? And a system is just as important as the materials. So you got to design the materials right, but you got to put them all together in a way that also will sustain the system over a long run. And that's thrust 3. And thrust 4 is enhancing the performance through innovations in safety, resilience, and connectivity. So these are the 4 thrusts, and they all lead into extending the life of our infrastructure. And we heard yesterday from Sid that the annual impact on the GDP of transportation infrastructure is what, 1.4 trillion? Is that correct? Imagine that every year the impact of our transportation infrastructure on the GDP is 1.4 trillion. Now, if you can make it last 10% longer, take 10% of 1.4 trillion, you can see what the numbers are. It's a very, very, very important problem. Now, I'm not going to go through all this, but there's been a lot of research projects that were developed in collaboration with the DOTs to help solve some of these tough problems. In the first thrust, you could see the number of projects that we have. A lot of them out there, from condition monitoring to different new sensors that are being used, to safety-related installations, intelligent inspection of infrastructure, wireless joint monitoring in bridges, and so on and so forth. As you see this list that's in front of you, you can see the depth and breadth of next generation monitoring technologies that are being developed at the center. In thrust area 1, there's a number of active research projects. You can see here researchers putting sensors on bridges, UConn students conducting tests for a project, and then an inspection of a new next generation bridge that was developed using at the center here in Hamden, Maine, and that's being tested in collaboration with the Maine DOT as well as researchers at UMaine and in Massachusetts as well. Some projects have been implemented as part of this work in thrust area 1. Is a major project that Professor Bill Davids have led up on the very top. It's field testing of existing bridges. As you know, oftentimes the analysis shows us that the bridge should be posted or the bridge should be shut down. And oftentimes you ask yourself, is it really ready to be shut down? Is there any more life in that particular bridge? And that's the question that Professor Bill Davids have asked himself. So he's developed some advanced numerical tools, analysis methods, as well as combined that with load testing to actually see if the bridge really needs to be posted or not. And what we found out is he's been able to save a lot of bridges from being posted or shut down. That's the big deal. That saves a lot of money. So can you get another 5 year on a bridge? Can you get another 10 years on a bridge? And that's really what Professor Bill Davis has done, and done very well. And that technology has already been implemented. Again, we've prevented a number of bridges from being posted or shut down. That's a big deal. Another technology you see at the very bottom is a new bridge girder technology that was developed at the University of Maine. And working with the Maine DOT, we've implemented that, as well as the U.S. Army Corps of Engineers. You'll be hearing from them in just a short while. So that's a collaboration between the U.S. Army Corps of Engineers and Maine DOT and our programs, and developed a new girder system that's quite a bit lighter than steel, will require less corrosion, lighter than steel and concrete, and it's made out of composites. And that girder, you could see in the picture, has slanted webs. It's like it looks like a bathtub, but it has slanted webs. And that the reason for that is to allow us to stack or nest the girders together so you could ship them. These are very light. We've been able, for example, to ship a bridge from Maine to Florida, that was made in Maine and sent to Florida. That's a 2-span bridge, a 2-lane bridge, about 60 feet long per span. All the girders were shipped on one flatbed. Now think about that. That's not, it takes a lot more trucks if it was a concrete or steel bridge, and that reduces the carbon footprint. The other unique thing about this bridge is you know how we oftentimes have to jackhammer concrete decks to replace them because of the way we cast them on steel girders. What we try to do with this technology is allow us to not have to jackhammer them when the concrete deck reaches the end of its life, whether it's 40 years or 50 years or 60 years. So, and working with the Maine DOT, what we did is we developed essentially a bolted connection, and and also the surface of the deck has a waved form, the surface of the flange, to allow us to mechanically anchor the concrete to the deck, and these bolts actually simply just keep them from popping off and sliding over. They don't carry things in shear. The shear is carried mostly by the waved top of the flange, and that worked very well. Professor Bill Davis developed this technology, and now 40 or 50 years from now, when the deck is ready to go, you can actually unbolt it and pick it up, okay, rather than have to jackhammer it. Think about how much time you save to do that in the future. So as we design bridges and new technologies, we're thinking about the entire life cycle from the, what does it take to fabricate the bridge? What does it take to get it to the site? What does it take to maintain it over its life cycle? And what does it take to actually decommission it? All of those are concerns that we're all working on together to develop a solution that's not just the lowest cost bridge that we can put in on day one. And that's a different way of thinking, and that's what our transportation center has been working on. And that's an example. If you haven't seen that bridge, I would say it's right. There's one right in Hampden, Maine. You can go to our website and see where it is and go visit it. It's a beautiful bridge that was installed in less than a day. The decks were installed in less than a day because it's a very lightweight bridge. Other implemented thrust area two, developing and implementing new material systems. And this is an idea that came up actually from the Maine DOT. There's culverts are being right now overcome by downpours, as you saw here just the last couple of days. Because of climate change, we're getting more and more extreme storms, whether it's in Vermont or Maine and other places. And the culverts get overcome and the roads get washed out. Can we increase the volume of water that goes through a culvert? So Professor Roberto Lopez Anito, working with the Maine DOT, developed a 3D printed culvert insert. And it starts in a circle on one end and it becomes an oval on the other end. By changing the geometry of the culverts from a circle to an oval, you create a Venturi effect that actually pulls more water through the culverts. And you can produce about 30% more water through that culvert. So if you insert that inside an existing culvert, you can run more water through it and potentially avoid having a bridge or road being washed out. But the question is, how do you make something of this size? How do you actually make a culvert insert that fits exactly within a culvert that's been built 30 or 40 years? You don't really know what the culvert looks like. Could you go scan that culvert and go ahead and 3D print an insert that fits perfectly in that culvert. And that's what we did. We 3D printed that. And then it's made in pieces, so it's easy to pick up. You could see the pieces, they fit together, and it's easy to pick up and put it in. And then my understanding is this week is the state of Vermont will be installing one of these here and try it out. And so, and the materials that we printed that with are 100% recyclable. They're bio-based and 100% recyclable. So when it's time to actually decommission the culvert, you can take that material, grind it up, and print something else with it. And so that's another example of where we're looking at more materials that have a lower impact on the environment. So I'm excited about this bridge and look forward to see it operating in Vermont soon. There's a number of projects that we've worked on, and we've also printed, Professor Lopez Anidos and others did some printed formwork for concrete structures. When you have a complex concrete structure, you can print formwork for that and put it in. It could be less expensive than making the formwork, stick building the formwork. So that's an example. If you go outside the lab, you'll see some of those outside this building, right at the entrance, you'll see one of the big pieces of formwork that was done working with the DOT. We've also been installing sensors on some of these bridges. You can see right down in, there's a lot of work going on, working directly with the DOT and with industry. This is more examples. The Penobscot Narrows Bridge in Prospect, Maine, has 3 carbon fiber composite strands, which are lighter than steel, are being monitored by the University of Maine under a particular project to compare steel tendons to carbon fiber tendons. These are the carbon fiber. See, looks like we're getting backwards for some reason. Advanced structural systems. This is how to take different materials and put them together to create systems. And I talked about that a bit earlier, but this is the new girder technology. We call it the G girder technology. And you can see how these girders were shipped from Maine to Fort Myers, Florida on one flatbed. So you try to do that with concrete and steel bridges. You couldn't put that many girders on a truck. You need multiple truckloads to do that, and that reduces the carbon footprint of transportation. And when these bridges get out there, also they're so much lighter. You don't need heavier cranes. You could do the installation of the girders with lighter cranes. And this is another view of the bridge that was installed in Hamden, Maine, and opened in December 2020. There's another installation of this technology. That's a double tub girder, where we have actually taken 2 of these girders, put them together with the pre-installed concrete deck on top, and then they're significantly lighter than other technologies, and then these can be put together off-site, and you can put a concrete deck on top of them afterwards. So there's a thin concrete deck on top of the double T girders, or double girders system. So that's another way to speed up the construction and mimic, if you wish, what we do with other material systems. And the final piece of this is the final thrust area is innovations in safety, resilience, and connectivity. There's a lot of projects that you see here. We won't have time to go through every one of them. Finally, I'd like to invite you to the exhibit hall and see what our sponsors and others are doing, and some of the students' posters. That's what you'll see in the exhibit hall. That's the double T girders, double G girders with a pre-installed concrete deck and fiberglass rebars. So this is an example of a bridge that we're looking at extending the life significantly, and the Maine DOT and others have actually installed bridges like this already. And you can see here the girders, lightweight G girders, and that's the bolted connection I told you about a little earlier. So 50 years from now, or 60 years from now, or 40 years from now, when the concrete deck needs to be replaced, you can unbolt it and put a new one in without having to jackhammer it. So again, I'd like to thank the Corps of Engineers, the DOT, and the Maine DOT, and others who've worked on that. And you could see here some of the concrete formwork pieces that were also printed. You could see them outside at the entrance of this facility.